drawings, you are getting all the required data, and then you are designing. So if you have a good understanding of these basic and how the load is transferred to the walls, to the beams, to the slab, that also is not given. Actually, you have to compute the loadings. Loading is one of the key part that is to be computed. And after that, the analysis part and then the design parts. Where here in this subject, we are emphasizing on the design part out of all, and of course, a bit loading computation part and analysis part you cover in the other subjects. So as far as this subject is concerned, um can you see the slides?
Yes, sir.
Is it on full screen or in partial half part?
Sir, full screen.
So my area of research, I have already told you, that is the design of structures, houses, buildings, tanks, long span structures, water treatment plants, concrete kind of structures of concrete mainly, masonry structures or concrete structures, composite also. And I have also working in the research part, which is a concrete properties, concrete mechanics, multi-scale modeling, supplementary cementitious materials, and sustainable development in the field of civil engineering. In this course, of course, it is OBE based, and you are well familiar already that there are certain CLOs, and CLOs are linked with the PLOs, and PLOs are linked to the PEOs. So overall, the program objectives are lesser than there are 12 PLOs, and for every subject there are CLOs. This system is mainly a lot of documentation have been added, and of course, this system, mm, when now you are graduating, you are not only getting the detailed mark certificate, but in addition, you are also getting the PLO attainment form. So that's why if you there are different domains of learning. One is a cognitive domain, the psychomotor domain, affective domain, and knowledge and understanding, and these are linked with the cognitive domain, mainly the theoretical part of the subject, and psychomotor is basically the skills. Not only the technological people are more related to the psychomotor, but here also in the laboratory class you learn some skills. Affective is your attitude and your manners and your interest toward the subject and solving the different assigned tasks. Training and knowledge and skills, all these are the part of this program. Overall, I mean, you have to see that in depth this program, that whether and how to attain the CLO, PLO, and if you feel that at final year level still your some PLO is not attained, so Every subject has a certain PLOs. So see that which subject is left and which PLO is linked to that subject. And then you can work harder in that subject to attain the required PLO, which is not attained in the previous semesters. There are other ways also to attain the PLO, if decided at the departmental level or in the teachers in charge of the subject. Mainly, this system is good, and there are certain objectives that you will be more relevant to the industry, enhance the relations, improve the avenues for internship, and OBE based accreditation. OBE based accreditation is basically nowadays PEC is only giving the accreditation to the universities who have opted the OBE system. So CLOs are basically PLOs are already defined by the program. These are also displayed in the department. Similarly, the PLOs are also fixed. There are 12 PLOs, and every subject is somehow linked with the 1-2 PLOs. In this subject, we are mostly linked to the design and development of solution. So PLO3 is basically commonly for the theoretical part. Now the topics that have already been started by Professor Dr. Kaisab is column. I will start the topic design of the column supported slab, and footing will be also continued by me, and development length by Kazi Saab, and then the water tank design also by me. In the column design, mainly we want to cover that you are able finally to design the different parts of the building. So columns, slab and footing, one multi-story building, more or less, and a tank. So all these elements are mainly designed. At the end of the subject, you should be able to handle the complicated design of the building's component. We will study in detail about the flat slab because you have studied already the one-way and two-way slab system, but here also the column supported slab will be explained. Individual and combined footing will also be explained, that how to design the foundation system, and how basically the loading is transferred from the superstructure to the substructure, and how to design the multi-column footing. And then you can calculate the development length and splices. Where the detailing of the reinforcement will be explained, and in the water tank design, we will design a circular tank in ground and on ground circular tank. These all PLOs topics and CLOs are linked with the PLO3. Mostly it is linked with the PLO3 design and development of solution. And the 100% strength of the PLO is given to the different topics. The lectures, of course, it's not like exactly the similar way because we have divided the topics and not the classes. So week 1 is the column is started week, and in parallel, I will start the flat slab design. Then the shear in this will be started by me, and Kazi Saab continue with this in his week, and similarly I continue with this flat slab design. in parallel. And then after the midterm, we will continue with the design of the foundation system and then water tank week wise. And Kazisa will continue with the column design, bond development and design. And some topics are part of the lab, which are the introduction to the strengthening, repairing, and rehabilitation of the structures. These are linked to the laboratory class. Then the introduction to the non-destructive testing and load testing. So although these are the theoretical topics, but we cover these topics in the laboratory class. So in this way, these are the different theoretical contents of the course, and these are the list of the experiments which are to be conducted: soundness of cement and aggregate crushing value. Concrete mix design is one of the lengthy jobs, then the casting of the specimen from the concrete, modulus of elasticity, core testing, Schmidt-Hammer test, portable ultrasonic pulse velocity, and non-destructive testing. All these tests will be conducted, and in addition, the two theoretical topics will also be explained in the class. This was about the introductory part of the PRC subject, and then now in the next part I will be explaining about the design steps involved in the multi-story building construction project. And where do we apply these knowledge of the PRC2, PRC1, and design of structures. So, of course, the steps which are involved in the building project now here you must know about the different things which are basically needed to understand, and you must have a general idea that where we proceed for the design and what are the importance of linking your discussion with the other engineers. You know that initially the site is decided and feasibility study is carried out for the project, and definitely the planning stage. It depends that whether it is a client is a government client or it is individual client who is making a building. So feasibility is done, planning stage is done, then rough architectural, they consult with the architect at this stage where the architect develops the plans and rough cost estimate is carried out. From the rough cost estimate, the PC1 is formed, and you know the planning commission performance, these are filled in for government project. For private, it is not necessary. And of course, the estimate and bill of quantities and these things are prepared. That what is the total estimate of the project. PC1 and planning and cost estimating and all these things are carried out, and once the project is approved by the concerned authority, whether it is a private project, it have to be approved, of course, from the either the municipal corporations in the seal or in the district level, or it can be from the development authorities, it can be from TMA, depending upon the requirements. So this stage is, of course, taking some extra effort, and you have to prepare the different drawings. Now, for all these things, for approval also, you have to prepare the certain drawings. When the project is approved, the architect will start working on the working drawings in consultation with other engineers like civil engineers, planners, environmental engineers. They discuss that what should be the requirement of the column sizes, what are the requirement for generators, for HVAC systems, and working drawings are prepared. The working drawings are basically detailed drawings and architectural plans are approximate but working is in detailed drawing. Then the submission drawing is prepared. Submission drawing which is to be submitted to the authorities, and the tender drawings if the tender is to be launched for construction of the project and different bidders apply that. So they also ask for the drawings. So tender drawings can be prepared or submission drawings sometimes work as a tender drawings. And of course, when the project is approved and assigned to the parties, then proper working drawing is prepared. The working drawings, which are now the design part, is of course there when the project is properly designed. Of course, the working drawings are being prepared. Then the different drawings which are involved in the project are architectural working drawing, structural working drawing, HVAC drawing, public health and electrification drawing. These are the minimum few types of drawings which are required for the work at site. Architectural drawings are first of all needed to be completed so that the structural engineer can work. Architect in addition work on the rendering, on the 3D interior and other things. Normally the 3D and these things and working drawings are helping the structural engineer to draw the structural scheme. So structural working drawings, here our work is in the PRC2 part that we are studying the subject. Here the civil or structural engineer is involved. We basically analyze the building, draw the structural scheme of the building, and analyzing, designing, preparing drawing of structures in consultation with the client, architect, planner, HVAC, electrical, all these we prepare the drawings. So the engineer is basically working and planning on this part of the project. Then we also consult with the mechanical engineer who is mainly responsible for the HVAC part, AC system, ducts. And you know that in the building there are a lot of ducts. I mean, pipes are running under the roof. There is a false ceiling which is hiding those pipes, but the pipes are the required water supply, sewerage system, HVAC system. So all these pipes are running through the under the slab of the building, and the public health engineer, environmental engineers are basically um, working on it. Water supply, sewerage system, drainage system, environmental engineer is responsible for that. The steps involved in the design is now the part is that how the engineer, structural engineer is working, and why we need the interaction with the other engineers, because we have to understand where the duct is needed, where the slab is to slab wide, the opening in slab is needed, where the generator is to be placed. So definitely we have to consult the other engineers, because if we don't consult, what happens that the drawings are not prepared properly and later on they have to cut the slab, they have to make the duct manually. So if we already consult with them and then we design accordingly, it will be better for the client and the contractor also. Then the steps involved in the design, there are the different, now what are the part which engineers are doing? Definitely the which data is given to the engineers. Data that is given to you is only the location of the project, the soil report. Normally the building type is also explained, type of the building. So that is the drawings, and architecture working drawings are also provided, where you can see the what are the building type, hospital or school, or it is a commercial project. because you have to see the loads from the according to the type of the building. So this is the first thing which is given to the engineers. Then the structural engineers are working on the developing the structural scheme or key plan of the structure, that what will be the structural scheme, walls, columns, 3D model is to be formed, and in the computer aided analysis and design, load computation is carried out, dead load, live load, seismic loading, wind loading, and many other. If let's say if you are designing the building in the snowy area, the snow load is also required. So load computation is more or less manual computation is carried out, and then we develop the model or analyze the manual or computer aided analysis of the building. Then after we get the reactions at the base of the building, based on the reactions we design the foundations of the building, and we have the forces in the columns and movement also. So based on that we design the columns, we design the retaining walls in the buildings, which is used to provide to retain the soil in basements on all sides. Where anything is to be retained, the retaining walls are needed. So then comes the floor system, slabs and beam design. Every floor may have same plan or different plans, so you design the slab system, beams there, and shear wall design, water tank design, generator slab design, flooring design. All these elements, lintel designs are carried out for the project, and then the detailed drawings are provided. So after all the design is carried out, then the working on the drawings is initiated, and initially the structural working drawing I am only emphasizing, although there are many other steps, but here I am emphasizing on the structural part of the project and the concrete design part. So which drawings are prepared by the engineers, structural engineers, are building layout. First of all, definitely the layout will be carried out when you decide the column size, grid lines. So column layout plan and the grid lines are decided in both the directions, in X and Y direction. Excavation plan is definitely decided, and based on the foundation sizes, from the center line of the grid, the excavation plan is marked and excavation plan is decided. And from that, the foundation system of the drawings is built. Foundation layout and foundation sections are basically decided, and this is designed by the engineers, and then you draw the plan and section of the foundation. The drawings are the finally deliverable, which are delivered at site. So if you must know how to basically check the drawings, you also should know that how to sketch these things, foundation section, column section, because engineers sketches and the draftsman built. So when you are guiding anything to the draftsman, you must explain them to all that how to make the drawings, what are the sections. So normally on the working drawings or on the structural scheme, print is provided to the engineers, and on that printout, the engineers are sketching the reinforcement, foundation design, and everything is to be explained to the draftsman, because whatever you draw or sketch manually, the draftsman will properly draw that on AutoCAD. Detail section of the elevation of the column, elevation section, you mean elevation along the height, slab system reinforcement drawings, basically this slab drawing for every floor, and beam framing plan. Beam framing plan is given that on every floor which beams are needed. Then the beam sections are needed, size and reinforcement, and general notes and specifications are prepared, that what is the strength of concrete, what is the double detail, what is the supplicement detail, what is the bearing capacity taken, what should be the mixed design. So everything is explained in the general structural notes and specs. So these are the part of the structural drawing: shear wall, water tank, staircase detail, flooring detail. So all these things is basically provided in those drawings. And when the drawings are complete, again the proper estimate is built by the engineers, that what is the total cost of the structural work, what is the cost of the architectural work, what is the total cost of the project, because these are the working drawings. So final execution is basically carried out on the basis of the structural working drawings. Then the construction of the project is started and then the completion of the project is carried out. Construction involved the different part, and I have prepared one of the smaller handouts. Please read those, and then the completion of the project. So mainly the structural engineering work is linked up to the gray structure finish, because the finishing things is carried out by the architect, then for the HVAC and piping system by the respective engineers. These things are taken care of. So I have in addition made the small handouts which are basically telling the different steps in building construction. Here is a flow chart also, that what is the hierarchy of the project, who is the leading architect and consultation, the steps of that, and then you can see the team which is at the project manager, engineer, quality control, senior project engineer, and this is the flow chart of the team. Here are the steps which are involved in the construction of the building: planning, excavation, PCC material, and then column layout is carried out, then the raft footing and the reinforcement in the raft, concreting work, column casting, then beam and slab casting, and then waterproofing, and all these things are carried out. So here is a brief explanation of the different steps is also given in these handouts. Column layout is carried out, column shuttering is placed, column reinforcement is tied. Plumb work, that the verticality of the column must be checked. So in this way, the different treatment and waterproofing at the end. So all these are the different steps. Here the summary is also written, that how this was from some internet sources. And in addition, one more handouts linked to the understanding about the different projects, steps involved for the different projects, construction and design processes. So here the construction and design processes are explained. So design and construction processes. Design and construction as an integrated system. In the planning of facilities, it is very important to recognize the close relationship between the design and construction, and these processes can best be viewed as an integrated system. So design include the detailed plan, specs, construction planning. Here in this project, integrated systems where the planning for both the design and construction can proceed almost simultaneously, examining the various alternatives which are desirable from both viewpoints, and thus eliminating the necessity of extensive revisions under the guise of value engineering. And the responsibility for the shop drawings So it is to be fixed on every engineer that who is responsible for making the drawings. There are different kinds of the drawings, and following the uh, this explained by the that how the different project in USA was carried out, and ASC manual was also prepared. Owner is not involved, but mainly the architect and the other parties are involved. Here the responsibility of the preparing the different drawing is fixed. Owner, design professional, construction contractor. And then is the here example of the metro project. What are the in Italian law? It was briefly explained. Then working on the innovation thing, new things in the project. It is explained. Then use of frame, structural frame. That which frame you select. Basically, there was an architect Fazlur Khan who basically gave different ideas in his research paper that which building can be selected for the different heights. In Pakistan, most buildings are 20 stories, 10 to 30 stories, so it is a rigid frame. If you have to make the building in the 100 stories, it is not possible, and you have to go for the bundle tube system. Recently, last year also, one of my MSc student and BSc work on the tube system. So these are for tall structures. Truss tube system, truss tube without columns, frame tube. So in this way, you decide the suitable system and innovation and economic feasibility. What is the cost of the project? And this is the average cost. Initially, with respect to the height, it is increasing. Then it start decreasing, and there is some optimum value which touches the average cost. Depending upon the labor hour also for the different area of the building. And then use of the new material should be encouraged. Sustainable material, we are working on the green building technology in the department also. Sustainable construction material, we are developing the new panels and bricks in the labs. So we should also emphasize on the, because civil engineering, the responsibility on the shoulder of the civil engineers is that you have to save the resources for the next generation. So for that, you have to be some wow for the go sustainable things. Design methodology is explained, and then the flow chart is explained that how you go for the design and what is the procedure of the design, functional design, different functions, hospital, school. So accordingly, the facility है तो what kind of different functions, how these are properly designed. So design is just not a work of a one person. A lot of teams are involved, and you decide the architectural design, that how many numbers are. One of the project was carried out for the medical complex by us, and it was also like properly. These are the steps normally when the architect is working on that, he properly see that in the hospital what things are needed, how many doctor rooms are needed, whatever the wherever the load will be there, and where the facilities will be provided. Bottom up and top down planning is explained. Physical structures. Then there are some examples from the different projects, that steel structure frame and water tank retaining wall project example. Five. This was a good journal handouts that I have read from the web, and it was self-explaining. So these are just reference handouts for your knowledge purpose. Please try to, these are the references used for making these handouts. These all references are used. So kindly go through these all handouts which are explained in the first part of the lectures. What are the steps involved, what is the role of the structural engineer, and how to carry out the any kind of the project. And where is your role as a structural designer? So if you have any question from this part, you can ask. First part of the lecture is over. You can ask any question. Thank you. Yes, any question? You can raise your hand or you can directly ask. Yeah, no one is asking. Yes, anyone? CR, you are there?
Yes, sir.
Okay. You tell me that what are the different input which are taken from the architectural drawings, working drawings.
सर उसमें से हम लाइक जिस तरह से हमने मतलब कोई बिल्डिंग है तो उसमें रूम्स बनाने हैं, उनकी डायमेंशंस वगैरह हमारे पास क्या होंगी, हाइट वगैरह कितनी है या कितनी स्टोरीज है हमारे पास, इस तरह से जो डिटेल्स है वो लेंगे.
Okay. Osama, you tell me that what information we get from the geotechnical report. Osama left. हसन अली आप बता दें. Hassan Ali, you are there? Hassan Ali is there? Yes, Hassan Ali. राकिब अरूज आप बता दें. राकिब है क्लास में आपकी?
Yes, sir. Yes, sir. Can you
What
repeat the question?
information we get from the geotechnical report?
सर जियोटेक्निकल रिपोर्ट में हम सोयल के बारे में मतलब हमें पता चलता है कि सोयल कैसी है, क्लेई सोयल है फैसिलिटी है, उसके बाद उसके डिफरेंट टेस्ट वगैरह होते हैं, तो ये चीज़ें हमें वो देती है जो टेक्निकल इन्वेस्टिगेशन।
मेन क्या एक आइटम आपको चाहिए होता है जिससे आप डिजाइन करते हैं? फुटिंग डिजाइन के लिए सबसे इम्पोर्टेंट पैरामीटर कौन सा होता है? bearing capacity होती है, allowable bearing capacity and depth of the footing, ये सबसे इम्पोर्टेंट होते हैं। वाटर टेबल लेवल, साइल टाइप, बट bearing capacity से आप एरिया निकालते हैं। Okay, then thank you, and after a break we will review the design that you have studied in the PRC1. Thank you. We'll join you after break, inshallah. Is on the mainly the whole tension is taken by the tension steel on the tension side, and compression is carried out by the concrete. You can see that the witness test block that for any singly reinforced beam, the compression is on concrete side and tension is given here. So similarly, this diagram you can see where compression and the tension forces are shown. So there is a 1 cc compression in concrete and T is the tension force in the steel. So this is a updated diagram, and you have seen that the singly reinforced beam rho is normally that you computed is less than rho max, and secondly when your depth is available, ample depth is available, and D provided is larger than the D minimum required, then you can go for the singly reinforced beams. This kind of beam is basically helpful because it gives the warning before the failure. It shows significant deformation also because on the tension steel yield. So this kind of the beam is preferable to design when you have the depth available option is there. Point is that when the depth is restricted by the architect and when you don't have the depth increasing option, your depth is restricted, then what to do in that case? So in that case, when your depth is restricted, and what happened that when you will go for the designing the beam, the depth that is provided is less than the D minimum required. So in that case, when the depth provided is less than the D minimum required, then this will become the doubly reinforced beam. You can see here, can you see the slides?
Yes, sir.
Yes, sir.
Yes, sir.
You can see here that in the doubly reinforced beam, uh, there are the steel in the both sides, so actually not only on the tension side but also on the compression side. Any side can be tension depending upon the bending moment. If it is a sagging case, the tension is downward. In the hugging case, the tension is at the upward side. So what happened that depth is lesser and D provided is less than the D minimum required, and due to that reason when you compute the rho value, the rho exceeds the rho max value, and that's why you need the extra steel larger than the rho max. That extra steel addition to the rho max is added in the bottom, of course, but that is also added at the top also. I mean, in the tension side, let's say the extra steel which is excessive to the rho max is provided on the tension side also, and that steel is also added in the compression side of the beam. Why? Because to balance the forces, you know that the force is when there is a steel on also on the compression side. So there are two kinds of the forces on the compression side. One is the CS compression in steel and CC compression in concrete, and one is the T, the tension in the steel on the tension side. So it means that the compression is taken by steel and concrete. If we don't provide this compression steel, what happened that the compression concrete can crush before the ultimate load even. So what happens that when there is a doubly reinforced beam, you need the steel on both sides. That's why it is called as doubly reinforced beam. But one point is there that the doubly reinforced beam normally it can be fail due to the reason that compression steel is yielding, and compression steel is not yielding. There are two cases, you can check it, and mostly it happens that it fails on compression side. So it is not a big warning of the doubly reinforced beam, because it is mostly, if it is a simply supported beam and it fails on compression side, then it will be crack will be developed at the top, because when the yielding of the steel occur, meanwhile the concrete also crushes at ultimate stage. So that's why the doubly reinforced beam is normally not common, but if it is to be provided, of course, in the house design, and when the architect restrict the depth, then you have to go for the doubly reinforced beam. But that is not an issue, because you can design it and the procedures are available. You can go for the reinforcement on both the sides. And this was the case that you studied, was the doubly reinforced beam, where there is a you can compute the reinforcement, excessive reinforcement, and based on that you can design the doubly reinforced beam. The expression these you have studied already are available. Then the case was of the T-beam. So the T-beam is basically so here you can see the T-beams, which are or L-beam. So what happens that when you are going for the T-beam provision, it's not the shape only, but also the depth of the compression, new compression block. Because you know that there are different options, you compute the depth of the neutral axis. So in T-beam, what happens that if your depth of the neutral axis is within the flange, it will not be a T-beam, because you will design that beam as a regular rectangular beam like this way. This is if the depth is lesser than the flange depth, flange thickness. And if the depth exceeds the flange thickness, it means that the depth of the neutral axis C is larger than HF. Here you can see it is in the websites. Now it will be designed as a T-beam. So T is a basically behavior, that what is your depth of the neutral axis. T-beam practically it's common, because most of the beams and slabs, if it is built monolithic, then you have to go for the T-beam. So A and C is, of course, if it is less than the HF, even the shape is mostly of the beam is like that. But if the A comes to be less than HF, then it's not an issue, because you will design it as a rectangular beam of this cross section. You design rectangular, but if the A exceeds the HF, then you will design it as a T-beam. If it is a positive movement, the tension will be on the bottom side, flanges in tension. One possibility is there, case one, and sometime it is possible that web is in tension. So both possibilities are there. So basically the T-beam is not like doubly. Actually, you get more steel on the tension side due to the T-beam. Why? Because the compression is on the flange also, and compression is in the web also. So the sum of the compression forces give the extra steel here. So one steel is provided due to the tension in flange, and one reinforcement is provided due to the compression in the web, and one reinforcement is provided due to the compression in the flange. So both compressions are balanced by the two steels. One steel you compute due to the compression in the web, and one steel you compute due to the compression in the flange, and total steel will be equal to the ASF to balance the compression in flange, and other steel is ASWFS to balance the tension in the web, compression in the web. So total steel will be computed and this T-beam is designed. So this was the case also you studied about the T-beam, where T-beam is a behavior. It depends that if only you will go for the T-beam design when the depth of the neutral axis exceeds the flange thickness. Then comes the design of the continuous beams mm, so continuous beams were beam which are one-way slab. The beams are one-way slab which are continuous, mean that there is no one span but resting more than one support. So continuous beam is basically a beam which is provided, of course, in many structures, and you can see that it is here you can see the continuous beams are beam which are more than the two or more spans, and in continuous beam the bending moment and these things you can see that is negative or positive, but ACI coefficients are available for the continuous beam. So what happened that it's basically it can be any kind of beam, either a singly, doubly or T beam. Mostly it can be like a T beam in the mid span sometime mostly, and also an inverted T beam at the sometime it is also a compression at support. The compression is at the which side? Bottom side. And tension is at the top at the support. So it mean if you are designing it as a T type of beam where the shape is like T beam, then you see that in mid span the beam section the tension is at the bottom side, and at the support the tension is at the top side. So therefore the reinforcement that is provided for this kind of beam is more reinforcement in the bottom of the beam in the mid span. More reinforcement is provided, and at the support the more top reinforcement is provided. So if the here in this part the web is in tension, and if in this part mostly the flange is in tension. So the T beam is basically the reinforcement detailing is like that. Continuous beam, there is a negative movement, there is a positive movement, again there is a negative movement, and then again mid-span positive movement. Conventionally it's like that. Due to the seismic loading the behavior may change, and you have to see the coefficients from this table. These are the tables from where you have to, these are the ACI tables, and you can see the coefficients. Similar coefficients can be used for the one-way slab. The next topic that you studied was the one-way slab system. One-way continuous slab. So that topic was actually based on the a bit different. One-way continuous slab behavior is also taken as the beam behavior, because there are mainly either a civil engineering structural component is a line element like column and beam, or it is a plate element like slab, or it is a shear element like a shear wall. So raft is also a plate element, slab is also a plate element, and shear wall is also a plate element but having shear forces dominant in it. Raft is a thick plate, slab is a thin plate, and column beams are the line element. And one-way slab is assumed to design as a line element because the same coefficient you follow for the continuous beam can be followed for the one-way slab system. So next the topic that you studied was the slab system. And slab system topic, one-way slab and the two-way slab was covered. In the slab system, you first understand that there are first you see the bending action while deciding whether it is a one-way or two-way slab. First important thing is that you must see the bending action, not the aspect ratio. Aspect ratio is the second criteria. Like say this slab is resting only on two sides. Whether it is a 4 meter by 3 meter, it will be one-way slab. Why? Because it is a resting only on two sides. So it will bend in one direction. If this slab is will bend only in the longer direction. So this is a bending action dominates it. But if the slab is resting on all sides, then you see the aspect ratio, shorter over longer. If the slab is resting on all sides, it means that the tendency of the bending of the slab is possible on all sides. So then in this case, the slab can aspect ratio is computed, and when the aspect ratio is lesser than 0.5, that slab will be designed as a one way. And if it is 0.5 to 1, shorter over longer side is 0.5 to 1, it will be designed as a two-way slab. So cantilever slab is always one-way slab. So mainly you design the slab system. I mean, these are the one-way slab examples where there is a one direction movement is dominant, and you can use the ACI coefficients for the one-way slab. Next type was that you studied was a two-way slab system. So two-way slab system is in the two-way slab system you discuss because the behavior is a two-way slab system. So the slab is designed as a shorter to longer span is basically 0.5 to 1. So that slab, this was the one way. Two-way slab is basically in this case larger than 0.5, and it is resting on all sides. There are different methods which can be applied on the two-way slab system. One method is the ACA coefficient method, one method is DTM method, equivalent frame method, finite element method. And this reinforcement is provided in both sides, but the shorter direction is taking the larger load, the longer direction is taking the lesser load. And ACA coefficient method is used where the movement is equal to coefficient you see from the table and load into span scale. You get the movement and design the slab. So this two-way slab was the first element that you design a plate element in the previous class, because all the other element, one-way slab, continuous beam, one beams, column, those are the line element. So slab is like a plate element which is behaving totally different than the beams. So that's why it's not easy to analyze it directly, because the two-way slab is a plate element. You have to see the end conditions, and then you see how many movement is present, and you cannot analyze it by the simply frame analysis. This is not a frame. So you have to analyze a plate element for the two-way slab system. So So in the two-way slab system, you see that it is a plate element. You decide there is a reinforcement on both sides, and negative reinforcement at the support is provided in the two-way slab. A partial minimum negative at the discontinuous. This is a discontinuous end with zero negative moment. Continuous end with negative moment, and mid-span having a positive moment. So you must understand the mainly the concepts I was emphasizing. If you have a good concept, you know how to place the steel, where to place the steel, where is a positive moment, where is a negative moment, because detailing is most important in the civil engineering structural drawings. So the slab is designed using the ACA coefficient method. You decide the thickness and effective depth, and then after computing the load, you see the coefficients, and from the coefficient you can compute the moment in the slab system. This was about the two-way slab system design. So then comes the design of the one topic was the shear design of the beam. You also studied the shear design of the beam. So the shear is basically, did you study the topic of the shear design in the beam? Yes.
Yes, sir.
Yes, sir.
शेयर का पढ़ा है टॉपिक आपने? In which you design the shear stirrups and the uh, so how we can control the shear in the beams? The shear in the beam can be controlled by increasing the depth or providing the shear reinforcement. So shear design of the beam was mainly you can see here that there is a 45-degree angle failure plan, and if you see the cracks of the shear, it occurs near the support, and these are the shear cracks. In the support region the shear is larger, and then you can control the shear by increasing the strength, increasing the depth of the beam, and providing the shear reinforcement. So if you go for the shear design of the beam, definitely you have to provide the stirrups, and stirrups are taking a reasonable amount of the shear, and you can compute the area of the web reinforcement which is needed, and then decide the spacing. There are certain criteria for the spacing of the shear stirrups, and out of that the minimum will be selected, and you can go for the shear design also. So these were the topics that you cover. Now our next topic will be there are certain limitations of the coefficient of the slab system. So next topic is again a slab system design, because the coefficient method can only be applied on the slabs with edges resting on all sides. The coefficient method, the big limitation is that one, that the ACA coefficient is only applied to the coefficient method is only applied to the system which is resting on all sides. And if the slab is not resting on any side but resting on columns only, then it is a flat plate. So next our topic is to design the flat plate system, a slab which is only resting on the column, because in multi-story buildings you know that there are a lot of ducts and pipe running under the slab. And if you go for a lot of beams, very deep beams, then the pipes, one option is to pass the pipe through the beam, which is not good option, because you can't make a lot of sleeves in the beam. That's why you go under the beam, and that's you need a lot of extra vertical basically depth is needed to accommodate the pipes. Overall, if it is a 20-story building, maybe you need the 40-foot extra space, but in 40 feet we can make 4 number of stories. So that's why, and to save the cost, Sometime the flat plate is constructed. Most of the multi-story building having a flat plate, flat slab with drop panels. So our next topic, we will start the flat slab design problem, because this method AC coefficient is not valid on that, and this is also a very older method. So that's all discussion regarding the review of the classes that we have already studied, and we can start the new topic next time. If you have any question, you can ask, please.